So what is the decision tree approach here? So the aim is to divide the whole population into segments, and each segment need to be useful for decision making. What do we mean by each segment need to be useful for business decision making? That means the segment need to be pure, or the segment should have one class really dominating. Then it is easy to classify the unknown items. That means if we segment out the whole population into two groups, in one group there should be more buyers, in the other group there should be very less buyers or more non-buyers. Then we can actually send a message that is related to more buyers. We can send a message, or it's very easy to make our decision, a business, easy to apply the business strategy. For example, I mean, it takes no great skill to say a customer has 50% chance of buying, 50% of chance of not buying. Anybody can say that there is a 50-50% of buying or not buying. A good split is like this. I mean, we give a rule, or we give one particular segmentation criterion and say that gender equal to female customers, they have 5% probability of buying, 95% probability of not buying. That means we have segmented out the whole population into a group where, I mean, two groups, where within one group we can actually say there are more buyers, the other group there are lesser buyers. So that is the whole decision tree approach. They divide the whole population into the segments, in which in each segment there is a huge dominancy of a particular class. So example, our sales segmentation based on age. So let us suppose there are 100 customers to start with. Now if I divide based on age, young and old, there are two segments that I am making. So age young, age based on age, young customers based on age, old customers. There are 60 young customers, 40 old customers. So out of 100, 60 are young, 40 are old. Now within these 60 young customers, 31 is buying, 29 is not buying. Within these old customers, 19 is buying, 21 is not buying. So at the overall level, I know 50% buying, 50% not buying. Even if I divide them based on age, young customers, within young customers again it looks like 50-50, nearly 50% buying, 50% not buying. Again in old customers, 50-50, 50% buying, 50% not buying. Then dividing the whole population based on age doesn't really help us, because we already know 50% of the customers will buy, 50% of the customers don't buy. Then why do we really actually need to segment out this population based on age, young and old? There is absolutely no difference between the buying pattern of young and old. They both have 50% of chances of buying. Now what is a good segmentation criterion? What is a variable that splits the whole population into two good segments? So here is an example. So the whole population has 100 customers. Out of them, some of them are male, some of them are female. There are 60 male customers, 40 female customers. Within male customers 60, there are 48 buying, only 12 customers are not buying. Within female customers, there are only two customers buying, 38 customers not buying. If you see, overall out of 50 customers who bought that product, 48 are actually male, only 2 are female. So within male there is 80% chance of buying, within female there is only 5% chance of buying. Now when I divide the whole population based on gender, then I can make really good business inferences. One is that lot of male customers, or most of the buyers are male customers, or most of the non-buyers are female customers. None of the female customers are buying. So dividing the whole population based on gender is actually giving us a better split, or giving us a better intuition to run a business strategy or to run a marketing campaign, rather than dividing them based on age, because be it young or be it old, they are not really different when with respect to buying, whereas being male, being female, they are very different with respect to buying. that is what we have to search for, such variables gender instead of the variable age. Okay, now the main question is we are looking for pure segment. So this is a pure segment, be it buying or be it non-buying. So this is a pure segment based on buying. So most of them are buyers. This is a pure segment with respect to not buying. Most of them are non-buyers. Okay, so we are looking for pure segments. Now dataset has many attributes. It has uh, what do you call age, it has gender, it has the place that their customers are coming from, the earlier previous orders, etc., etc. So which is the right attribute for pure segmentation? How do we identify whether age is a good one or not? How do we identify whether gender is a good one or not? Or is there any better attribute that even can make into two good segments? Okay, can we start with any attribute? Okay, which attribute to start with? Is there any best separating criteria for attributes? Customer age can impact the sales, gender can impact the sales, customer place, demographics, etc., etc., everything. I mean, out of all the variables that we have in the data set, we just can't have one or two variables. If there are multiple variables, how do we find out which is the best split attribute? The factor, the variable that is very good at dividing the whole population into two groups that are very pure. By very pure, we mean to say one group is dominated by the one class. I mean, if our class variable is buying, not buying, or if our class variable is for marketing, response, not response, which attribute that does a good job of dividing the whole population into pure classes. Here in this example, this is a pure class, most of them are buyers. This is a non-pure class, this is also a pure class, sorry, most of them are non-buyers. So how do we actually find out that attributes? What is the splitting criterion? Which variable I should choose for splitting? What is the splitting criterion? So what is a splitting criterion? What is a good splitting criterion? The best split is the split that does the best job of separating the data points into groups, whereas each group has very dominant single class, whereas a single class really dominates in each group. That means if we divide the whole population into groups, when we say the splitting is really good or the best split, when we say the split is best, that means the groups that we see as a result of splitting should have purity, either one group dominating really high. If we say let us take an example of age. Is this a best split or is it a good split? So at the root level there is a 50-50% of chance of buying or not buying, or 50% positives, 50% negatives. Okay, now after the split there is 52% positive, 48% negative in young group, 48% positive, 52% negative in the old group. So this is not really giving us pure splits. This is not really giving us something to take a business decision upon, because we did not gain really any information here. At the root level or at the population level, there are 100 customers, 50% of them buy, 50% of them don't buy, 50-50 chance. Even at the split level, the customer segments level, young customer segment, old customer segment, both of them have almost like 50-50% chance. So this age variable is not really a good splitting variable. Whereas this gender variable, so at the root level again 50-50% chance, but at the individual splits we see male population and female population. Male population has 80% chance, female population has just 5% chance. That means like 95% of not buying. That is also pure from the point of view of not buying. male population is also pure from the point of view of buying. So this split is very much better than earlier split based on age. So we are looking for, variables like gender. We are looking for variables that will split, and that will result in final pure segments. So impurity or diversity measure. So what we are looking for is an impurity or a diversity measure that will give us high score for this age variable. That means age has a high impurity, we would say. Even after segmenting, it is not really giving us pure segments. By pure we mean to say one class is really dominating the other. We can actually say one segment is buyer segment or non-buyer segment. It is not really giving that the age variable, so that is really impure. Whereas gender variable has pure segment. So we are looking for an impurity measure or a diversity measure which will give very low score for gender variable, because gender variable is resulting into pure segments. We can actually look at the segments after based on gender, and we can say yes, this is a buyer segment, the male segment is a buyer segment, the female segment is a non-buyer segment. So gender is really adding value, okay, to our segmentation. Age is not. So we are looking for an impurity measure. So is there any mathematical formula? So entropy characterizes the impurity or the diversity of a segment. So finally the impurity measure that we are looking at is entropy. So entropy is measure of uncertainty or impurity or the diversity, okay. Entropy measures the information amount in a message, okay. If S is a segment of training samples, okay, P plus is the proportion of positive examples, P minus is proportion of negative examples. So if you take one segment, positive examples, proportion of positive examples here in 50%, 50% is negative examples. Here proportion of positive examples is 52%. In this segment, male segment, proportion of positive examples is 80%. So P plus is proportion of positive examples, P minus is proportion of negative examples. Then entropy is defined by this formula, minus P plus into log 2 into P plus, again minus P minus into log 2 into P minus. So this formula actually defines the impurity. If you look at it carefully, it's very intuitive. The formula is defined in such a way that it is really high when the segment is really impure, okay. When P takes a value of P takes a value of exactly half, that means 50-50 choice, 50-50%, that means very highly impure, then entropy value is the highest. When the segment is pure, that means 0% one segment, 0% one class, second class is 100%. In that case, entropy value is almost the split is really cool, really pure. Then entropy value is the least. So when P takes the value 1, either P plus or P minus, then entropy is the least. When P takes the value 0.5, that means very impure, then entropy is the highest. So entropy anyway characterizes impurity. So using this formula, we can calculate the impurity, we can calculate the diversity at each segment. That is how we can actually quantify the impurity, which will be later used in deciding which variable is splitting purely, which variable is not splitting purely. Very lot of diversity is there, so we can actually get that based on entropy. So once again, entropy is the highest when the split has probability of 0.5. So entropy is highest when the split has so we already discussed that it takes no great skill to actually say a probability. There is a chance of 50-50% for yes or no, 50-50% for 0 or 1, 50-50% for buying or not buying. So that is that means when we are saying probability is 0.5, that means it's most impure. So let us see, let's calculate the value of entropy when p is 0.5. So p plus is 0.5, obviously p minus is 0.5. We are taking log to the base 2. So if we substitute 0.5 here and in place of p plus, 0.5 in place of p minus, then we'll get an entropy as 1. So if you take this whole value, this is zero point 0.5 and this whole value is again 0.5. So this is negative 0.5, this is negative 0.5. Finally you can calculate that and you can see entropy is 1 for p 0.5. Now let us take an example of pure splitting, pure segmentation. So when a variable really splits it purely, then what happens? So one of the probabilities will be 1, other probability will be 0. So if p plus is 1, then p minus will be 0. I mean, uh, if everything is one class, the other class will have obviously 0 probability. So entropy, let's calculate entropy when one of these values is 1. So let us take 100%, 100 and 0 class ratio in a segment that is really pure and entropy is low. Let us calculate entropy. So if p plus is 1, so log to the p plus, and p minus will be obviously 0, the second class probability. So everything is 0. So entropy value here, you can see that entropy is 0. So log to the base 1. So entropy value is 0 when you have pure classification. Entropy value is 1 when you have very impure classification. So the lower the entropy, the better the splitting, the more pure the segmentation. The higher the entropy, that means the more impurity or the more diversity in the segment, the more uncertainty, then it will be difficult for us, or it's not really useful in making the decision. So that is how we do the entropy calculation. So the less the entropy, the better the split. So entropy is 0, that is like very highly pure split. So entropy actually is formulated in such a way that it will take care of this highly pure segment should get low score. That means low impurity, and highly impure segments or highly uncertain segments get high score. Okay, so that is how the entropy formula is created. So let us see an example of calculating the entropy. It's not that every time we have to calculate the entropy. Just to get a better understanding of entropy, we will see a simple example of calculating the entropy value for a given segment. Now let's take an example of this population. There are 100 customers at the root level, and then we divided them into two groups, young and old. Young has 60 customers, old there are 40 old customers. At the root there is a 50% positive, 50% negative. Obviously there is a lot of impurity, in fact highest impurity here. There is no real there is no real information here, 50-50 chances. But let's calculate entropy at the root. So we know the formula of entropy. It is negative of minus proportion of positive into log 2 of proportion of positive minus proportion of negative into log 2 of proportion of negative. So you can see the formula here, and at this root we have probability of positive, which is 0.5 into log 2 of 0.5. Probability of negative is again 0.5 into log 2 of 0.5. When you substitute all the values, when you calculate, you'll get the entropy value as 1, that is like 100% impurity at root. That is understandable because there is a 50-50 chance at this root level. Now let us calculate entropy for this particular segment young, which has 60 elements. So segment 1, age equal to young, has 60 records. Out of them 31 are positive, 29 are negative. So the positive ratio is 31 by 60, negative ratio is 29 by 60. So when you calculate entropy, you will get the actual value of entropy as
0.999181984, which is like almost 99% impurity in this segment, which is understandable because Young didn't really, I mean, this segment didn't really give us any additional information. Out of 50-50, we got nearly 50-50 positive negative only. Similarly, when we calculate the entropy for this segment, the second segment old, which has 40 elements, out of that 19 are positive, 21 is negative. When you try to calculate the entropy, so segment 2 age equal to old, this segment has 40 records, so 19 by 40 into 19 log 2 of 19 by 40, etc. When you calculate that, you will get an entropy value or the impurity value or the uncertainty as 99%. Again, that is again understandable because it is almost like 50-50% chance. So that is how we calculate entropy and see how pure a segment is or how impure a segment is. Here both young and old, these two segments are impure. Now let us you can try one more example of calculating entropy based on gender. We have already seen for the root the entropy is 100% impure here. So what is the impurity for this segment, that is male segment? What is the impurity for this segment, that is female segment, which has 40 uh, 40 records, two of them positive, 38 negative. Looks like this must be a pure one. This is somewhat pure but not really pure. 48 positive, 12 negative out of 60. Let's calculate the entropy in those two segments as an exercise. Now when you calculate the entropy, entropy at root will be 100%. You have already seen that entropy at root when you calculate 50-50. Obviously when there is a 50-50 chance, entropy at root is 100%. Now entropy for the male segment, that is 48 divided by 60 is the positive. This is positive probability and log to the base 2 of this one probability, and then 12 is the negative number of negative items, so 12 by 60. So entropy is still on the higher side. Again, that is it is considering 48 and 12 within 60. That's why entropy is 72%. There is still 72% impurity in that entropy, I mean impurity in that segment. Now female segment, if you consider female segment, there are 40 female customers. Out of them 2 have bought, 38 haven't bought. In that case, when you calculate the entropy, 2 by 40 is the probability of positives, 38 by 40 is the probability of negatives. When you calculate entropy or impurity, finally the impurity is 30% or like 28.6%, which is a real good indication that this is a pure segment. You can actually name this as, you know, really nearly pure. You can actually say that as this is a negative segment, like 38 negatives are there, so 95% of them are negatives. You can say if negative indicates not buying, then you can say female segments are non-buyers of this particular product. So that way, I mean, the purity, based on the purity, you can actually make the business decision. That's how we calculate the entropy. Now there is one more measure which is nearly connected to entropy, that is information gain. Information gain gives us a better picture on a variable based on its splitting criterion. So how good is a variable doing, or how well a variable is segmenting out the population, or before the segmentation what is our what is the knowledge that we have, what is the information, after the segmentation what is the information gain that we have gained from the population or the split that we have just performed. So information gain is entropy before split minus entropy after the split. We'll see that for a better understanding. An easy way to understand information gain is, so overall entropy at the parent node minus sum of the weighted entropy at each child node. So we have some information at the parent node. After splitting, did we really gain additional information? Can we really see purity increase? At the root node there is no purity. That is the reason why we actually gone ahead and split that into two partitions or number of segments. After segmenting them out, did we really gain any additional information? That is what information gain is all about. So we can find, we have many attributes, we can find information gain for each attribute, and the one which has the maximum information gain is the best splitting attribute. So before that, first let's try to understand what is information gain using an example.
Now let's see how to calculate the information gain. So information gain calculation. So we have the overall population at the root level that has the 100 observations. Now we have divided the population into two groups, two segments, young and old. So each one of them have their own entropy. Entropy at the root level is 100% impure because 50-50 chance. Entropy at this segment is different, and entropy at this segment is different. So what is the formula for information gain? Information gain is entropy before the split minus entropy after the split. After the split there are two segments, so how do we calculate entropy, one entropy value after the split? We can take the weighted average value. So entropy after the split, let's say for young segment entropy is 99%, for old segment entropy is 99%. We can actually take the weight of this segment, which is like out of 160 people fall here, so 60 percent into 99 and 40% into 99. So entropy before the split is 100% for this segment, 100% impure segment. Entropy after the split for young segment is 99 and the old segment is 99 again. So 100 minus 0.6 into first segment, 0.4 into second segment, which is like information gain is simply 1. That's it. So the information gain when you split based on age is very low. It is just simply 1, not more than that. Now let's come back to a different variable called gender. So entropy before the split at the root level is 100%, so it's 100% impure. Now is gender really giving me any lift, or is it giving me any information? So let's try to calculate information gain, that is entropy before split 100%, entropy after the split. For this segment, for male segment entropy is 72%, for female segment entropy is 29%. So how do we calculate entropy after the split? So before the split minus 0.6 into, so I'm calculating the weighted average here, 0.6 into 72% here, because male population is 60% of the overall, female population is 40% of the overall, so 0.4 into 29%, total information gain is 45.2. So we have the overall entropy at the root level, and then information gain when we split it into segments. We can actually find out entropy before the split and then subtract the entropy after the split. That gives us information gain. There are no hard and fast rules that information gain should be this much or this much. We can actually compare between the variables. The one with higher information gain is given more preference. Generally information gain in and around more than 50% is considered to be a good lift. Okay, information gain, if it is near to zero, obviously we are not seeing any significant lift over the parent population. If the parent has 50-50 chance, even the segments are giving 50-50 chance, then there is no purity, then information gained is nothing. Whereas if the leaf nodes are or the child nodes are giving us a little bit of pure segments, that means one class is really dominating, then information gain will be higher in such situation. Similarly, there is an exercise which you can try this out. So there is I think response yes or no, response positive and negative. So
with respect to owning a car, the population is divided into two groups. Yes, some people have car, no, some people don't have car. So you have to calculate the entropy and calculate the information gain. And population is divided based on gender also. 40 are male, 27 are female. Out of them, some of them are positive, some of them are negative. So this looks very tricky. So which one has higher information gain? Is it owning a car that is giving us a higher information gain, or is it gender that is giving us a higher information gain? So how do we calculate information gain for this particular two splits? So overall impurity at the parent level, that is 28 positive, 39 negative, so impurity is 98%. Now owning a car has owning a car has 25 positive, 4 negative. So when you calculate the entropy, it is 57%. Entropy for the second segment, not owning a car, is uh, 3 positive, 35 negative. Not owning a car has an entropy of 40%. Information gain is entropy before before the segmentation, and entropy after the split, sum of entropy, weighted average entropy after the split. So entropy information gain here is 50.6. Similarly, if we calculate for male female segments and subtract it from the entropy of overall population, we will see value of 10.3. Information gain for gender here is 10.3. For owning a car is 50.6. Definitely the first variable has a better lift. Then we would say the variable, if we split the whole population with the variable with respect to owning a car, then we might see a better result in segregating the customers. There are other purity or diversity measures apart from entropy and information gain. All of them are leading to the same point. Given the variable, given the segmentation, how pure the variable is splitting the whole population into. So even entropy and information gain are telling us, how good is the variable in dividing the whole population into different groups, so that each group is representing either all ones or all zeros, a particular class. Then only we can actually apply our business logic very easily on that. So there are other measures like chi-square, Gini index, information gain ratio, misclassification error, etc. All of them are going to tell us the same information. So each one of them might work very well for a separate type of problems, but the basic intuition is entropy and information gain. Given the overall population, yes, there is some impurity at the overall level. Can I split the population and then achieve purity and then segment out so that all the customers behaving very similarly within that each segment?